to be showing some of the features that I've been working on for EVE-NG. First of all, I've changed out some of the networking code that's used inside of the lab that allows the nodes to communicate with each other. Basically, I've replaced all of the Linux bridge code for open virtual switch code, and that allows me to create a mirror for a bridge, and I'll show you that in a minute. So if we just close some of these windows. If we create a new node, normally you see a long list that shows you all of the templates that are available, but I've changed that code to show only the templates for which we can utilize. So basically the ones that we have images installed for. So now that I've added Docker inside the code, we can create a Docker node. So when we select a template, we then are given the option to choose an image. So these are all of the Docker images that have been installed on the system. So for this one, we have a custom Wireshark VNC image that I'll be demonstrating. For the RAM, I fixed the code so it limits the amount of RAM that the node can utilize. So the Docker node can only, in this case, utilize a gig of RAM. And then we also have a new option here that allows you to select the console. So when we select telnet, VNC, or RDP, it will redirect the console to the Docker node on the default ports. And we also have the option to override it. So if we're running something other than VNC on port 5900, for example 5901, we can specify that here. But for this image, it uses the default port, so we'll just leave this blank. So we'll go ahead and save the node, and then we'll start the node. And when the node starts, we can connect to it using HTML5, a guacamole interface. So this is our, we just slide this window over. This is our newly created Docker node. And the next feature I want to show is the ability to capture traffic directly to this Docker node that we just created. So normally there is a handler, I should say normally when you want to capture traffic, there is a client package that you have to install that basically when you right click here and go to capture and select an interface, it redirects that to the handler, which allows it to do a local Wireshark packet capture. But I've rewritten that code to allow it to redirect directly to this Docker node and attach the interface there. So I'm going to go ahead and create two routers. And connect those two routers. And now when I start these routers, you'll see on the right hand side the bridge being created. So this is OVS, Open Virtual Switch, and when you start the nodes, it will automatically create the bridge and then create the ports and attach them to that bridge for the node. Now that we have the nodes running, we can right click on one of the nodes and we'll just select the interface that's attached to R2, and we'll tell it to start capturing. We see our notification, and we see a new capture interface appear on the same bridge. So inside the virtual switch, what it did is it specified this port on R3 as a source and destination, and it's mirroring the traffic to this newly created interface, which is then attached to the Docker node over here. And we can see that if we go into our Docker node and refresh Wireshark, we should see a newly added interface, which we can. And if we start capturing traffic, we don't see anything yet, but let's configure an IP address. Tell it no switch ports. And then we'll give it an IP address of 192.168.1.1, Class C subnet mask. You can see that we're up, and we see our gratuitous ARP come through.